So continuing on with solving log equations, we want to basically put this into one log. So we get log base 2a, that's going to be power 4. Okay, so then we combine those by multiplication, so we end up with power 5 on the x, and that's equal to 3. If I want to solve for x, okay, and I think we're solving, although we could solve for a, I'm going to solve for x here, so I'm going to end up with 2a. If I put cubed here, this is a problem that I was talking about before. We cannot put the cube on the a. It has to be 2a all cubed equals x to the power 5. And then solving for x, we get the fifth root of this, so 2a to the power 3, the fifth root. Okay, so there's my solution for a. Now, we could have done this the same here. I'll do an alternate solution here. This is kind of the more straightforward way, but we could have done it this way. We could have said that we had 5 log base 2 of a 2a of x. Okay, we could have said we had 5 of them because they have 1 here, 4 here, and they're all the same thing. Okay, so we have 5 of those same things. So we can count them that way because we are counting with pluses. And then we can say, well, this power on this side should end up with a divide, times on this side ends up divide on this side, which is really a power on this side, ends up as a root on the other side. Okay, so I end up with 2ax equals 3 divided by 5, and then solving for x, we get the exact same solution. We end up with 2a and the 3/5 power. Notice that the power 5 then shows up as a root 5 on the other side of the equation. So lastly here, we're looking at identities. Okay, identities are expressions that are true. What we're being asked to do is to show the steps to show that they're true. Okay, so we want to be able to show some steps to show they're true. So some strategies here, we have a fraction here, we don't have a fraction here. We've got base 3 here, we've got base 10s here. So one thing we can do maybe is to convert it to base 10 or all the same base. In fact, base 10 seems more reasonable because converting to base 10 does two things. Convert to base 10, which is the same on the other side, but it also generates a fraction, which is what I kind of need. Okay, I need a fraction on this side. Okay, so I have a power 4 on this side. I don't have a power 4 on this side. So maybe there's either I can introduce a power 4, okay, but then I have to do that same on the bottom, okay, to balance it out. Or I could take out the power 4. So I don't know what to do here. So I'm just going to maybe simplify this because these are compatible. You know, this is a base 3 number, that's a base 3 number, and I can put them together. And I know that I have 3 to the power 4. Well, I can kind of see what's going to happen now because that power 4, if I bring it out, I can cancel those power 4s. I can introduce power 4s on this side to make them the same. I'm going to do this using my log property. Log, the power 4 comes outside on both numerator and denominator. Okay, so these are on the outside now, so I can divide. On the inside I can't divide. On the outside of the log I can divide. Okay, so there it is. There's my proof. Left side equals right side. Okay, so these are identity proofs. Some of them can be hard, some of them can be easy. Again, have some strategies. You want to make them look the same, and you want to use proper algebra, whether the log algebra, for example, bringing the 4 on the outside is log algebra, or times divide algebra, which we're doing here. And don't mix them up. We cannot do times divide algebra on these arguments inside the log.